Hello, and welcome to my webinar on decrypting RDP traffic in Wireshark. So before I begin, I just make a quick introduction. I'm Marc-André Moreau, CTO of Devolutions. In a past life, I started the Free RDP project. We also started the RDP project at Devolutions to rewrite RDP in Rust. And as a side project, I made MS-RDPX to extend a first-party RDP client on Windows for usage in Remote Desktop Manager. Today's presentation was originally meant to be presented at the RDP I/O Lab at Microsoft, but for some reason they decided to cancel all their guest speakers. So lucky for you, we have the presentation a month ahead today for a lot more people than what would have been presented to at RDP I/O. For context for the presentation, it was originally meant for developers, people who implement the RDP protocol. But if you're a system administrator, someone who just likes to understand what goes on over the wire, especially people in InfoSec or security analysts, you will love this presentation because in some cases, even if you're not implementing the actual RDP protocol, you may want to just look at what happens in the packets, and you are able to just go and look at the protocol specifications and figure out what exactly is going on, especially when there are no logging capabilities involved on either the RDP client or the RDP server. So it may look difficult, but it's not that difficult, and it can help save you a lot of time in diagnosing for diagnostics of very precise RDP issues, especially authentication issues, which is 80% of the issues that we look at during our work at Devolutions. So let me begin and dive deep into the subject right away. So there are many different techniques for decrypting traffic, TLS traffic. So RDP uses TLS, so that's not a secret. Older versions of RDP did not use TLS, but we're not going to cover that. But of all the different techniques, this is the one we'll be using today is TLS pre-master secret logging. This looks complicated for not that much. What this means is when you make a connection with modern TLS, I'm speaking of TLS 1.1, 1.2, 1.3, is you have your server key, which is used to authenticate the key exchange. But then what you actually use for encrypting the traffic is a key that was derived from the key exchange. This is called a TLS pre-master secret. And it's called a pre-master secret because it's the original secret, which is used to derive multiple keys during the session. If you can extract those keys, then you can decrypt the TLS session that matches it. Windows uses S-channel. S-channel is a secure channel, which is used for TLS. So a lot of applications in Windows use that TLS stack, including RDP, but LDAP also uses it. WinRM for PowerShell also uses it. So a lot of built-in Windows protocols use S-channel. So the technique I'm showing today is usable for RDP, but usable for other protocols in Windows. So you may want to try and reuse the same tooling, but I'm focused solely on RDP for today. The thing is, S-channel uses the LSA, or the Local Security Authority, for protecting those pre-master secrets. So when your application makes a connection, it doesn't actually have direct access to those secrets. They're actually in a separate process, and it's a protected process. There is one benefit to that is that, well, they are protected, but they're all in one place. So you don't need to inject into several different applications. You can have it in one place. Other TLS stacks like OpenSSL or Embed TLS and the other ones, they don't necessarily do that. So it's very common to see applications support an SSL keylog file environment variable in which the application will accept it and start dumping those TLS pre-master secrets into a text file. Here are my references for how you extract TLS pre-master secrets from the LSA. So I didn't do the research work. I didn't even do the original code. I just took it from a friend. But the blog post here has all of the details on how you hook the LSA and grab it from the Encrypt APIs. So you attach to the LSA, and then you API hook a few function calls that deal with those pre-master secrets, and then you can dump them to a file. A good friend of mine, Jordan Borian, wrote a PowerShell module called PS Detour. It's literally the Detour library from Microsoft, but in PowerShell, so you can start scripting your API hooking. And then he made a script following the first blog post that would attach to the LSA and then start dumping those TLS pre-master secrets into a text file that we can use. So this is what we'll be showing today. I reused that and I made a PowerShell module out of it for convenience. The other techniques for decrypting RDP traffic, well, the second one, which you may want to use but not that much, is at the application level. So you're implementing an RDP client and you want to dump the packets. Well, you have them in your RDP client. Chances are you're probably not developing your RDP client, so you don't necessarily want to do that. I tried doing it in the Microsoft first-party client on Windows, MSTSC by API hooking, but it's very difficult. You have to reconstruct TCP/IP headers. It's a cooked capture. It's not real. You hit tons of issues with Wireshark not liking the fact that it's not a real capture. So we're not going to cover that. Just know that it may exist, but it has tons of drawbacks and issues. So the best, really by far, is figure out a way to extract those TLS pre-master secrets, and you'll be in business to decrypt the traffic. Another technique you may have heard about, may work for a lot of other protocols, not that much for RDP, is why not make a network man-in-the-middle proxy. Problem man-in-the-middle proxying is the beginning of the RDP connection sequence. RDP NLA, or CRED SSP, has built-in man-in-the-middle protection. So the thing is, it echoes the server's public key. If it changes in transit, even if you trust a certificate, it will detect it and abort the connection immediately. This makes it really hard. The other issue is that RDP has a tiny exchange before the TLS handshake begins. This is called the X224 negotiation that negotiates RDP NLA, TLS, or the ancient pre-TLS encryption. This tiny packet here just makes it non-standard, so you cannot use a regular proxying tool that would expect a clean TLS handshake to begin after the TCP connection happens. Last but not least, CRED SSP echoes the server's public key, but the authentication, the NTLM or Kerberos authentication that happens during CRED SSP also has a feature called extended protection for authentication. It has a channel binding token. So it binds the TLS session to the authentication that happens over it. So if you try to use a reverse proxy that swaps the certificates by another trusted one, like so many security products would do, well, this will get blocked as well. If you've ever used Fiddler, Fiddler has to disable that specific feature if you want to intercept Kerberos traffic over HTTP. So it's the same problem in RDP. And this is old material. If you've ever seen blog posts on how to do this, a lot of them probably mention extracting the server RSA private key and then sending it into Wireshark so it can decrypt any traffic that connects to that same server. The problem is this only works with older versions of TLS, and so TLS 1.1 and TLS 1.2, but only with the weakest ciphers. There's this thing in cipher suites. You have suites that will let you do perfect forced secrecy. And what this means is if you compromise the server private key, can you decrypt future sessions? So modern TLS makes it such that if you compromise the server key, you cannot decrypt future sessions. But this is what this old technique relied on. If you extract the server private key, well, now you cannot really use it, which is why we're going to use TLS pre-master secrets. So just to summarize, the technique we're going to use is TLS pre-master secret logging. To do it in Windows, we have to extract those pre-master secrets from the LSA or LSAS, if you're more familiar with the process itself. We're not going to cover application level packet logging, but just know that it may exist. Network minimal proxying. I know there's PyRDP that exists, but it's for a very different use case. It's not really something we're going to go with. I would write it off. It's not really an option for us if you just want to inspect what's going on. And then forget about server RSA private key. If you read about it, it's old auditor material. Don't even try to use it. Let's get started with the most simplest how-to on how to get some RDP traffic decrypted. So the prerequisites. Right now, what you should have at least is a test Windows VM in which you can RDP into. This is the bare minimum. If you want to have something functional, just create a VM with Windows in it. You can RDP into it. we're good. I insist on using a VM. Don't use your host, don't use a production device, because the first thing we're gonna wanna do is to disable LSA extended protection. You may have noticed that if all the secrets are in the LSA and the LSA is a protected process, well, you probably want to disable security features that go with it, and there are consequences to that. So definitely don't do it on your real device. You will be able to decrypt RDP connections to and from that device. So if you go into that test Windows VM and then RDP into another machine, you should be able to decrypt that too. So it works for the server, but also the Microsoft RDP client. In that test VM, install Wireshark, because we're just going to do everything locally inside that test VM. We'll see in the second step how to decrypt from a separate machine. If you want something much more elaborate, you don't like building labs yourself, you only have one test VM, and then you don't really know how to set up Active Directory and all those things. Well, good news, I have a set of scripts you can use. This is an optional step called Devolutions Labs. I have the URL on top. It's a set of scripts to build a Hyper-V lab that we use internally at Devolutions. So I built this, I updated, and the goal here is to have everything set up for developers to just launch this and have a full Active Directory lab with RDP, ADCS, certificates, everything set up, even RD Web, a connection broker, licensing server, such that you can just test their stuff while developing Remote Desktop Manager or Devolution Server or Devolutions Hub. So if you didn't know about it, it's really great. Optimizes for local developer usage, and this is what I'm using for my daily testing. In your virtual machine, here are the steps to just bootstrap it from a clean Windows install. So you want to disable the LSA extended protection. You need to reboot after that to make it effective. You need to install PowerShell 7, and yes, it's required for PSD-Tor. Just to explain a bit of the black magic that goes on here, to attach to the LSA using PSD-Tor, we're literally loading PowerShell 7 inside the LSA, which is nuts. So I helped Jordan on making that technique happen, but this is why you need PowerShell 7. The technique does not work with Windows PowerShell. And as usual, on fresh Windows machine, well, you want to disable the execution policy on PowerShell, because we're going to just run unsigned PowerShell scripts. So once you've done that, you rebooted your VM, you need to install a PSD-Tor PowerShell module, install it for all users, so scope all users. Then you're going to use a PowerShell module I built just for this presentation, the Coding Debug Tools. So I made commandlets that just streamline the process. Otherwise, I had way too many steps on how to do it. So I installed this module. And then from your elevated PowerShell 7 terminal with the PowerShell module install, start LSA TLS keylog, and you leave it running. You will see a line at the terminal that says it's logging TLSP master secrets from the LSA with a path in the temp folder. So this is perfect, just leave it there. In that VM, if you don't have Wireshark installed yet, just install it. So just go download the MSI installer or use Chocolate or Winget, but just install Wireshark into that test VM. Once Wireshark is installed and running, you want to go into Preferences, navigate to the TLS section under Protocols, and then you will see this configuration parameter there, the pre-master secret log file name. This is where you need to put that same path that was printed at the terminal. So by default, it's C Windows temp TLS LSA.log. So this is what my PowerShell module will log to. Now, in the Wireshark, you want to start the packet capturing. So if you're not too familiar with it, you just go into capture options and you wait a little bit and you look at the traffic graph. You see which one is probably the one you want. It has network activity on it, and then you click Start. Simplest thing then is to just make an RDP connection to that machine or to another machine, and to put this filter on top, tcp.port == 3389 or udp.port == 3389. If you're already RDPing into that machine, you have the current session that will come up into that filter, unfortunately. So make a new connection, because you need to watch the TLS handshake happen for this to work at the bare minimum. So the new connection should start appearing. And if everything worked well, you should be able to start decrypting some of that RDP traffic as shown in the screenshot. Everything I'm presenting today, the material, it's all into that first GitHub repository. So github.com/awakecoding/Wireshark RDP. I just pushed the slides to this presentation into the documents folder of that repository before starting this presentation. So if you want to follow, or if I went too fast, you want to go and see the slides, well, it's there. Otherwise, well, you have it right away. So go there. You will also need it later because I have a set of sample capture files into that repository. So we're going to use that for the demo part. And then if you're curious about what the PowerShell module, the Awake Coding and Debug Tools PowerShell module looks like, you go in the GitHub repository. You have the full code that uses PS-detour in there and all of the other goodies I added to simplify the process of extracting those TLS master secrets. Now, that was the simplest case. You've installed everything into one machine and then it works, but the thing is, this is your test VM, which you disable the extended protection. And you develop from your host, which has all of the tooling and the security tooling from your company. And you certainly do not want to disable security features in there. But this is where you develop, but you decrypt in there. So how do we go further and start doing the decryption where you need it? So in this case, I have a test Windows VM to RDP into, but I'm developing for my corporate laptop and I want to decrypt this traffic. My client is on my host, but I want to start logging those TLS master secrets remotely because the goal here is I want to extract them from the LSA running my test Windows VM, but I want Wireshark in my host to have those pre-master secrets. How do I do that? In your test VM, you have your first terminal in which it says that it's logging TLS master secrets from the LSA. Keep that window open. You need it there. Open a second one, and then type in this command, start TLS keylog server, log file. This is optional, but this is just to specify explicitly the same log file in which is being logged to the LSA. Port number by default is 12345. You can override it. But this is the default, and allow in firewall. So I just made it in one command. You just start TLS keylog server. It will pick up the one from the LSA, use port 12345, and it will just add a firewall rule for it. And what this will do is it's a small commandlet that will watch the file for changes and stream them to any TCP client that connects to it. On your host device, you can install the Awake Coding Debug Tools, and then type start TLS keylog client with the IP and port of the machine and the destination file name that you want to use. Here, instead of C Windows temp, I use env temp, which is not C Windows temp. It's a different temporary directory for the current user because you may have issues with the file permissions if you try to use C Windows temp. But the goal here is in my test VM, I have my TLS master secrets extracted from the LSA. I have a TLS keylog server that just watches for changes and streams those changes to any TCP client connected. On my host device, I have a client connected to that server that receives those TLS master secrets and streams them to another text file. So you want to install Wireshark on your host device, you don't have it already, and it's almost the same procedure as before. You just go and point to your temp log file, in which that I call this time TLS all because I'm logging all my TLS master secrets into it. And you should now be able to decrypt in Wireshark from your host when connecting to that test VM. Now, you may ask the question, okay, now I can connect to that test VM and it will decrypt the traffic. But what if I want to connect to the other VM or the other one? Well, I thought about that too. So what you can do is in each of the test VM that you have, you start the LSA TLS keylog, then you start a TLS keylog server. And then on your host, you can actually pass it an array of IP addresses and collect from multiple sources at the same time. So if I have 5 VMs in my lab, I can just launch the server 5 times. And from my host device, I can connect and collect the TLS master secrets and aggregate them into the same keylog file. What about logging TLS secrets when I'm not using S-channel? If you're using FreeRDP or using a product based off FreeRDP, well, there is a way to do it at the command line. So it's TLS secrets file, command line argument, then you can pass it the full path to a file. This is more for developers and necessarily for regular use cases, but I'm still mentioning it. And if you're using RDP or developing RDP, it already accepts the SSL keylog file environment variable. So many other software that do not use S-channel have similar options. So these are the options for FreeRDP and RDP. Now, even if you can decrypt the traffic, the next problem you'll face is you'll have a lot of background noise, or the RDP connection uses features that are not well supported by the dissector in Wireshark. First thing you want to disable unless you specifically want to debug UDP or develop UDP is just disable the UDP transport. It makes it much harder to filter. You cannot do like TCP. You have to use like TCP.port equal 3389, but then you have to add the UDP.port. It makes everything so much harder. You cannot right click and follow TCP stream because you won't have the UDP stream. So just disable it. If you're using MSRDPX, you can actually edit the .rdp file with disable UDP transport. This is not a standard option added in MSRDPX. Otherwise, there's this registry key in the slide, which you can just set, and it will disable UDP for all of the client connections from that same machine with MSTSC. The other thing which is very noisy inside the connection sequence in RDP is the bandwidth auto detection. So you will have a lot of traffic at the beginning. It creates a lot of noise. It makes it hard to compare connection sequences easily because of this noise there. So add to your .rdp file the three options at the screen: connection type to 6, network auto detects to 0, bandwidth auto detect to 0. And one of the most important one, disable bulk data compression. Bulk data compression, unfortunately, is not supported by the Wireshark dissector. So all you see is compressed data. You don't want compressed data to just show up. In Wireshark, you want to see what was the uncompressed data. Now, you have configured Wireshark to use your TLS premaster secret file. Problem is, you want to share those captures to other people. You don't want to just send a text file and have them every single time go to preferences, protocols, TLS premaster. It's way too painful. We're in luck, because when I began doing this work, there was no simple option from the Wireshark GUI, but they added the option now. You can actually inject those TLS secrets in the capture file. So in Wireshark, you go into Edit, Inject TLS secrets. That's it. So as long as you've loaded the TLS premaster secrets, you can just go into that menu and inject them into the pcap.ng file. The pcap format does not support TLS premaster secrets being embedded into it. So you absolutely need to be using pcap.ng. Alternatively, if you're not at the GUI and you want to do it well separately or automatically, you can do it at the command line. Use it edit cap with the inject secrets command line, which is shown on the screen. Unfortunately, it does not support doing it in place. So you have the issue of having to use a different output file than the input file. So it's a bit more work. So I much prefer to do it from the GUI when you're doing it. And then last but not least, you want to export a clean capture file. You go to File, Export Specified Packets, and make sure that Display is selected. This is my preferred technique for using a filter in Wireshark and then exporting using that same filter. So just type in your proper filter at the top, but then when you go to export, make sure you use this technique of using only the displayed and not the captured packets, because you will have a lot of background noise from other machines on the network. You don't necessarily want to have that into your capture. Just one thing to make sure to not remove everything. Oftentimes your RDP connection, we have out-of-band Kerberos traffic. Make sure that your filter includes that, not necessarily exclude it. And if you're doing TCP only, well, TCP only, you will have, it will be much easier to just follow a specific TCP stream. And maybe you don't need the extra Kerberos traffic. So the simplest thing will be just to find which connection it is, right click it, and then to filter on just that single TCP stream, and it will make a clean capture properly. And then you can also use the option to compress with gzip or LZ4 for your pcap.ng. So if you're making long packet captures with a lot of graphics or even file transfers, they will grow quite fast. You probably want to use the compression in this case. There are 3 main methods for capturing packets in Windows. The most common one is using npcap. So this is the option you have when you use the installer from Wireshark. Listen, do you want to install npcap? Yes, and then I went download and launch the installer. The thing not necessarily everybody knows is it's great, but the silent installation option requires a special license. So this is a problem for the scripts for the lab I shared earlier for Devolutions labs because I automate everything. So I cannot install npcap properly. So right now I'm still installing WinPCAP, which can be installed silently, but honestly, every single time I launch Wireshark in one of those test VMs, I have to reinstall npcap because WinPCAP is deprecated and unmaintained. Still works, but not that well. You want to use npcap most of the time. Last but not least, there's a built-in tool in Windows called packetmon, and packetmon would be awesome if only it were integrated directly into Wireshark for live capturing, but it isn't. If you're in a machine that doesn't have Wireshark installed, though, this is perfect because you can just like open an elevated PowerShell and then just type a few commands and make a packet capture on the fly. This may be useful if you're capturing traffic from a customer site. Well, putting the LSA TLS master secret extraction aside, you can have the capture done this way. Fortunately, it's a bit painful to type all these commands. You need to remember them. So you can add a capture filter, or you may not add a capture filter or just capture everything on the machine using pkt packetmon filter add RDP filter. Then you can specify a port like port RDP 2389. That will work for TCP or UDP. Then you need to start the capturing. Packetmon start capture, packet size 0. For some reason, you need to add a filter to capture all packets properly. And then you need to specify a file, an ETL file. It's not directly to a pcap-ng. Once you're done with your capture, you need to do packetmon stop. And then to export that ETL file to a pcap-ng using packetmon ETL to pcap, the ETL file, and then specify the capture the pcap-ng file. And then don't forget to remove a filter if you no longer need it, because it remains persistent until the next reboot, I think. It would be really great if Microsoft just contributed an equivalent of npcap using those same APIs used by packetmon, because this is great for capturing, but you don't get live capturing. Live capturing will be amazing. Now, for the demo part. I mentioned earlier the Wireshark RDP repository. So github.com/awakecoding/Wireshark RDP. This is where I collect all my resources on decrypting RDP traffic in Wireshark. If you don't have that repo yet, go and download that repo. That repository has a captures folder. And this is where I have a README file that lists a short description of a large variety of packet capture samples, already with a TLS pre-master sequence embedded. So all you need to do is literally to just install Wireshark, download those files, and just open them. There is one capture I'm using for most of these small demos, and then we'll do an actual live demo at the end with questions. Go and use RDP and the lake Kerberos auth1.pcap-ng. So I have a couple of slides in which they just show good filters you may want to use to find specific data into that capture. So the first one is CredSSP or with the 2 pipe characters or Kerberos. Why? You're diagnosing Kerberos related issues. You want to catch the out-of-band Kerberos traffic to the KDC, and you want to catch the beginning of the connection, the CredSSP part of the RDP connection. So with that filter, you will see both. So you will see the traffic going to the KDC, and you will see the RDP underlay traffic. And then you can start inspecting. In that screenshot, I'm just showing the name of the server, which is in the Kerberos bucket. But there are many different things you want to use. Oftentimes, issues will involve like an improper Kerberos round being used or Kerberos not being used at all when you expect it to be. So things like that. Next filter you want to use is rdp.clientData. You have a client data packet and the RDP connection sequence, and it has a lot of interesting things. For instance, you can find out what the client hostname is. It's literally client name, and it's into that packet. So you may have heard of reverse RDP client attacks in which the client is connected to a malicious RDP server. Well, know this, the RDP client sends a lot of data from what the client is. So malicious RDP servers will grab that information and figure out a lot more things. For instance, they may also know the client time zone. So if you want to figure out who connected to your server, well, you have their machine name and which time zone they're currently using. That may help a bit. If you're curious about the RDP virtual channels, so there are two types of channels in RDP, the static virtual channels, which are initiated at the beginning of the connection, and then you have the dynamic virtual channels, which we'll cover later. But if you want to find out the list of virtual channels which are being opened, rdp.channeldef_array will find the packet that contains it. Then in this case, you have RDP-DR for device redirection. So this includes disk redirection, smart card redirection, and a couple of other things. RDP SND, RDP sound. So well, it's quite obvious, but it's limited to 8 characters, so they had to shorten it. Clip RDR, clipboard redirection. So this is one which may be interesting for clipboard data. Oftentimes, clipboard data may contain sensitive information. So if you're into InfoSec, this is something you want to look at more closely. And DR-DIN-VC has a weird name, but this is actually a static virtual channel used for dynamic virtual channels. So it's turtles all the way down. You just build on top of the old things. If you want to filter for a specific static virtual channel, you can try and figure out its ID from the traffic, and then you can use a filter like T124, the channel ID, and then the channel ID of what you want to look at. In this case, I just figure out what the channel ID was for clip RDR, and then we see that nothing happens except the beginning of the clip RDR virtual channel traffic. So no copy paste happened into that specific session. Then I spoke of the time zone. If you want to find the time zone, use rdp.clientinfo.pdu. Has a lot of interesting things. It has, for some odd reason, the path to the RDP ActiveX DLL. It means absolutely nothing. In FreeRDP and RNRDP, we just repeat that same string. So just know that we don't change it. We just use the same one as MSTSC. But you have the client time zone. So if you want to know this information, it's in there. Lots of more things you can have. Just look at it and you will find more. You have the protocol specifications you can look up online to figure out what may be available. RDP.capability set. So at the beginning of the connection, you have an exchange of what is called capability sets, which are used to negotiate features. This is where it gets a bit more disappointing in Wireshark, because you have the whole list of capability sets, but literally almost none of them are fully dissected. So you will have a couple of bytes and then just the name of a capability set, and that's it. So if you want to inspect that, definitely refer to the protocol specifications, figure out what the bytes mean, and hopefully someone will contribute improvements to those to the Wireshark RDP dissector in the future with complete dissection of the capability sets. But this is very important. You're trying to figure out why the codec is not being negotiated properly. You probably want to go into those capability sets to look at what it is. I highlighted an interesting field here called source descriptor. And what the source descriptor is, it's literally just a descriptor of what the RDP kind may be. And here it says MSTSC, but in FreeRDP we set it to FreeRDP, and in RNRDP we set it to RNRDP. This is how you can know that Azure Bastion actually uses FreeRDP in the Bastion host, because when you capture traffic from the destination server, well, guess what? It says FreeRDP. So we know for 100% certainty they're just based off FreeRDP. In fact, they're using Apache Guacamole in Azure Bastion, which is not really secret. Everybody knows that it's pretty much Apache Guacamole package as Azure Bastion, but this is a way to confirm that it is actually the case. If you want to start digging more into the dynamic virtual channels, there are different ways you can do it, but if you go, there's a filter called RDP_DR-DIN-VC. What this weird name means is device redirection for dynamic virtual channels. You need a mnemonic trick to remember that weird name. This is what it is. If you type rdp.DR-DIN-VC.cmd == 1, this is the create packet. So this is the packet which creates the dynamic virtual channel. And dynamic virtual channels, unlike static virtual channels, they are opened by the server. So the server initiates the opening of the virtual channel. So if you filter on those messages and you go and click on one of the packets and select channel name, you can right-click on that field and select apply as column. And this will add a channel name column, and then you can easily see the dynamic virtual channels that were open inside that session. So here we see a telemetry, virtual channel, graphics, video control, video data, geometry, input, display control. Display control is used for the dynamic resizing, was added in RDP 8.1. Input is used for, well, they just revamped the whole input protocol, so it's actually duplicated from the core protocol, but it was originally only meant for multi-touch. Now it actually duplicates the core input events or the traditional ones as well. And kind of forgot what geometry was, but yeah, you can just look at those names in Google. You will likely find the corresponding protocol specification for what that protocol is. Now, with RDP 8, there was a big shift in how the graphics were transmitted to the client. It's all into a dynamic virtual channel called EGFX. And EGFX is basically the RDP 8 graphics pipeline. It reuses a lot of the older codecs. So you may have RDP 7.1 remote FX, NS codec. You have clear codec, which is used for text encoding in a special way. But you have newer variants of different protocols. It also has primitives for making solid fills of images, caching images, things like that. So it all goes over that virtual channel. So if you're trying to figure out what goes wrong with your RDP 8 graphics pipeline, which is what will most likely be negotiated if you're connecting to a Windows RDP server, that's the case, well, almost never the case if you connect to a non-Windows RDP server, well, the filter you want to use is RDP_EGFX. And then here I just highlighted one of the commands there. You can see there are multiple commands. A command ID map surface to scaled output. Yeah, I almost forgot that you can actually do that. But there's an EGFX protocol specification. Just look at the specification and look at those messages. From what I've seen, it actually dissects most of these messages properly in Wireshark, so you can inspect most of what happens there. I don't think there's a way you can easily see the images, but maybe someone will build a tooling in the future to make that happen much more easily. Now is the time for questions. So we'll look at what's on the screen. We have two questions. Okay. Yes, the comments are in PowerShell, and I made a PowerShell module to simplify the process. This will work with any RDP client. So if you decrypt from the server, you can actually decrypt from the Microsoft client or from Android, iOS if you connect to that same RDP server. But it will also work for FreeRDP or RDP. Also work if you use Remote Desktop Manager, which supports, well, the RDP aspects from Microsoft, but FreeRDP and RDP as well. So this is really useful because you just need to decrypt from one or the two endpoints. So I recommend decrypting from the server if you have a non-standard client or a client you don't want to instrument in any way. And on the other side of things, if you're working on the server, you probably want to decrypt from the client and figure out what the interaction is and make the conversion this way. Will TLSP master secrets work for TLS keys for HTTP traffic as well as the RDP TLS communication? This is a tricky one. From experience, I don't understand why, but sometimes it does. And the places where I've seen it work is when inspecting Azure Virtual Desktop calls made to Azure. And it's probably because it's using built-in Windows APIs, maybe WinAPI. I don't know what APIs it is using, but I could inspect it, including the embedded web view. And why is this so confusing is because modern Microsoft Edge no longer uses Edge channel at all. When they made the switch to Edge Chromium, well, they ditched Edge channel. They're using boring SSL now. So I'm not sure why some traffic would be decrypted, because from my understanding, you need to be using something that uses the LSA if we extract the secrets from there. So it may or may not work depending on which APIs are being used for HTTPS traffic. But what I can confirm, it works for HTTPS traffic that uses built-in Windows API. So everything using WinHTTP will certainly work. Some of the embedded web views from Windows will work. So the pop-up for the logging to Azure actually works from experience. But you'll also be able to decrypt LDAP traffic, LDAP-S traffic. This is super useful. And partial remoting, you will be able to decrypt if you're using WinRM over HTTPS because it's using TLS. Partial remoting not using TLS uses a different type of encryption. That technique won't work for that. So I have a question about does the capability support TCP tunneling TCP traffic? That's a good question. I don't have the link off the top of my head, but I think somebody built a SOX over RDP virtual channel extension. So just Google it. If I will try to find, otherwise reach me. I will try to find what the project was. I haven't tried it myself, but I know at least one person built a tool to do exactly that. So on the client side, it would actually be a localhost SOX proxy, but it will go over an RDP virtual channel to the destination host, which obviously also needs something running in the server, which is non-standard. So it's an extension, it's not into the built-in protocol. That is not an extension which is standard at all. So it's a third-party extension in this case. Another question about, is it possible to capture Hyper-V virtual machine connection traffic using this method? It depends. I would have to try it because it actually goes over the VM bus. So I don't think any of the TCP-based capture methods would work in this case. But if you manage to capture the traffic and export it to a PCAP-NG file, I don't see why you wouldn't be able to. But I will have to come back to you on this if it's possible to do it from the Hyper-V connection. If you do it from a remote machine, that I can guarantee, because maybe you meant it more, if I open Hyper-V Manager and open it locally on the same machine, it will definitely go over the VM bus. But if you open Hyper-V Manager to connect to another Hyper-V server and then open it using VM Connect, that should work. That is guaranteed it should work. Just know that when this happens, it's not using port 239. It's using another port I forgot. I think it's 2179. It's a different port. It's not the standard port because it's actually a server running in a Hyper-V host. Even if it's using the enhanced session mode, when it's going through a remote connection, it will go through that Hyper-V host server and then redirect to the RDP server inside that inside the guest over the name pipe. So we just redirect traffic this way. Otherwise, you just connect to the host and it doesn't connect directly to the guest. It has an RDP server in the host. So there are two methods of connections for a virtual machine connection. If you're interested to digging more to Hyper-V internals or Hyper-V Manager internals, you can go to my blog at webcoding.com. I have a full blog on how to decompile Hyper-V Manager and rebuild it from source just to learn how it works. So this blog may be of interest to you. The encryption for the RDP, well, it's DTLS. It's basically a TLS version for UDP. So it should work as well. So if you extract a TLS pre-master secrets, normally there shouldn't be an issue with RDP UDP traffic. I recommend turning it off because it makes it much harder to filter on specific sessions of RDP. Makes it much more noisy. So if you disable UDP, well, you have a clean TCP session with all of the RDP traffic in it. So unless it's relevant to the issue you're investigating, just turn it off. It will make your investigation much more easier this way. Any recommendation on RDP except from the famous MS-RDP BCGR, which stands for a basic connectivity graphics remoting or something. There are overview documents. So if you find the famous MS-RDP BCGR document, you'll have all of the MS-RDP something specifications. But there's another section in the Microsoft specification, which is just called overview documents. Go into it. There is one about RDP or different parts of authentication as well. You want to look into those documents because they give a very high level view of the mess that is like the hundreds hundreds of protocol specifications in RDP, and it may be difficult to figure out your way around, but start with the basic one, MSRDP PCGR, go into the overview documents, and then just find your way around which documents may cover the part that you need. With your method, is it possible to see the login and password? Not if you're using RDP NLA. The reason for that is I only covered decryption of TLS traffic. If you're using Kerberos, this is something I haven't tried myself, but I know is possible. You need to extract the KDC tab from your domain controller if you want to do it, because it will actually be the corresponding secret to the username password, which is encrypted based on the Kerberos exchange that happened during CredSSP. So just to explain how CredSSP works, CredSSP will make NTLM or Kerberos exchange such that both, in the case of Kerberos, the client and server will mutually agree that they know the same password in some way, and then agree that the client will say, okay, now I can actually delegate my credentials to you. But the trick is, well, they've negotiated an additional session key by doing this Kerberos exchange, which is used to encrypt the full credentials. And those full credentials are sent to the RDP server, and then they're literally just passed over RPC to WinLogon. So you may not see the WinLogon interface, but it's literally just almost doing the same thing as pasting the username password to WinLogon when it does that with RDP LLA. But this is why you want to see the username and password. This is also why it's very difficult to make a malicious RDP server that would collect those credentials, because you need to be able to respond to a full NTLM or Kerberos exchange with knowledge of the credentials. Thing is, if you have access, if it's a domain account, or if you have access to a domain joined machine, you may be able to call the Windows SSPI APIs to respond properly to this exchange, but you may have issues with the CredSSP server public key echo if you're decrypting the traffic, not necessarily using the same certificate. But if you can manage to decrypt the TSP master secrets and then can extract the KDC tab, I think you should be able to do it. How can RDP seem to randomly prompt for passwords upon connections? Is it because Kerberos? Well, good news. Decrypt the traffic and you will figure it out. There are many different reasons why this will happen. Don't forget to include in your filter Kerberos, because you will want to look at the traffic going to your KDC for obtaining the tickets. It's normal that you see a first message that says pre-auth required. It's almost like HTTP authentication. When you begin, it just says, well, you need to authenticate every single time, as if it wasn't obvious. But it begins with this. So you will see it will say, you need to pre-auth. Okay, I need to auth. It will request a ticket, will request another ticket, but usually we'll follow the first one. And then you look at the details of those messages. These are not even into the RDP and NLA exchange. This is for obtaining tickets with your KDC. You will often have issues with the username format being used, and you will also have issues with the realm being incorrect, especially if it's on a machine that is not the same as the domain to which your machine is joined. Sometimes what I've seen is, for some odd reason, it will pick up a default Kerberos realm, and it will send that realm to another domain that has, well, no link to that domain. So obviously it doesn't work. There is some odd behavior about like trying different things you may see. So I'll try one thing, one other thing like that. So when we re-implemented Kerberos from scratch for our products in the SSPR RS, I should maybe mention, we have Kerberos support in our RDP web client based on our RDP, because we'll re-implement all of our Kerberos properly. It actually goes through, we have a KDC line of sight made possible by Devolutions gateway. So if making Kerberos work in many different cases is very important to you, definitely just look after this presentation into Devolutions gateway. It works for the web, works from RDM, but we just make Kerberos work, period. Trademark. But yeah, you can take my word on this, we make it work. But to go back to your original question, yes, look at the beginning of the connection. So it will probably be before you, the actual RDP connection happens. It will be in that traffic. Otherwise, it may be during the RDP NLA, usually fell before. Maybe what you will notice is that Kerberos doesn't happen at all. don't forget that for Kerberos to work, you need to use the fully qualified domain name in most cases. And then you also need to use to have a KDC line of sight, which the client will know where to find. So oftentimes it may just be that it doesn't know how to detect it or needs manual configuration. Normally it works fine within a domain because of the necessary detection of the domain controller. But when you're connecting to other domains, well, this is not available. So you may need manual configuration for that. Can you explain the PKU2U problem with Android joint device? How much time is left? Because I have a blog post on how horrible it is. I don't have that many solutions to it. So PKU2U is this horrible solution that was invented, I think, back in Windows 7 for workgroup machines to connect to other workgroup machines with some sort of centralized PKI or something like that. It's weird. It wasn't designed for what it is used today in Entra ID joint. It's literally just a patch that they said, well, at least we have a way to make it work, but it has horrible UX. So if you want to look on the nightmare of PKU2U on my blog, you will have all of the preconditions required to make PKU2U work between Entra ID joint devices. All it will show you is that your username and password are invalid for like 5 different reasons with literally no way to tell which one it is. So you need to manually enable PKU2U on the client. You need to manually enable PKU2U on the server. You need to use the proper name, username format, and force it to have Azure AD into its domain. Well, it's all in there. It's very complicated. It has a very poor UX. I doubt many people use it daily. A lot of people recommend disabling RDP NLA because they never figure it out. And the only reason why it works when disabling RDP NLA is because you get a remote when log on and then you type in your password on the remote machine. And that remote machine is probably Azure AD join and knows everything that you need to know from the client. So it's very difficult. And it only works for password-based auth. If you've seen it work with something else, I've seen like weird reports from people telling me that some things magically work with no explanation on how. Well, let me know, because I'm still trying to figure out how it may work with non-password based auth. It makes no sense to me. There's no explanation in the protocol on why this would work. It shouldn't. There's a replacement to PKU2U, which is the Azure AD SSO, or now Entra ID SSO. It doesn't have the same requirements as the original PKU2U. So your client machine does not need to be Entra ID joined to the same Entra ID tenant, but you get a web login and you have no way to properly log off from the client yet. I think somebody reported a month ago or 2 that maybe they saw an update and there's a new option in MSTSC to log off from the client, but for the first 3 years, it wasn't available. And I have yet to confirm that it actually does what it says it does. I have a question about someone asking if we're going to do the presentation in French. Well, if you're from Quebec or if you want to come to Quebec, we have ITSec this summer. And I will be reusing the material from this presentation to make a 2-hour training session on how to decrypt and inspect RDP traffic, but it will be entirely in French. And so I will do a different presentation using the same material. It will be longer. It will be entirely in French. So maybe this is something you'd like to see. If you cannot attend in person, well, I will post the slides in French later in the same repository. You have my presentation from ITSec from last year in the same place for ITSec 2024. That was mostly on how to diagnose issues using logs and different techniques that did not involve decrypting the RDP session. Sorry for those that don't read French, just put it in ChatGPT. It will help you figure it out. But I recommend that you just look at that other presentation as well. So no, stay in English. We will stay in English, no problem. So all of this material will be available in English anyway. Was there another question, or are we out of time? 5 minutes. Did I miss a question? Last chance? Well, in this case, don't forget to look at devolutions.net for our products. I recommend looking at Devolutions Gateway. It's quite interesting. If you're into making Kerberos work, we do help a lot of people make that happen. This is why I had to build this tooling to figure out what goes wrong. well, on Blue Sky, so devolutions.net on Blue Sky. I have my blog, whitecoding.com, and where I post a lot of deep dive into different technical topics. Also on Blue Sky. So if you have any questions, just reach me on Blue Sky, and I will be happy to follow up with you. Yeah. And someone's typing. Thank you. Well, it's been great. I hope you enjoyed the presentation. And don't forget, you have the slides immediately on the Wireshark RDP repository. The recording to this session will be published later. But for now, you can already go and get the slides. So thank you again. I hope you enjoyed it. And have a good day. Have fun decrypting RDP traffic.